Right, we're looking at proportionality now. These are usually sort of B grade questions. They can crop up on a non-calculator paper or the calculator allowed paper. The ones that you can print off, the ones that I'm going to go through now, I've written in the margin whether they're non-calculator or calculator allowed. First chunk, I've gone for a non-calculator questions. The key things that you need to pick up from these questions are parts which I've just underlined there. Y is inversely proportional to X. The Y and the X are the variables that we're going to put into our expression, and whether it's inversely or directly proportional, you're going to use a little sort of fish symbol, alpha, the Greek letter alpha, to show proportionality. If it's directly proportional, then it's just Y proportional X. I will look at that in a minute. If it's inversely proportional, and all the questions that I have found are in fact inversely proportional, then it means it's 1 over. So we'll see how that looks now. So given that Y is inversely proportional, proportional means instead of the equal sign you're going to use alpha, and it's inversely proportional means 1 over, and what it's inversely proportional to is X. So that's the relationship that we're dealing with. Now, the way to think about this is that if you look at your calculator, even though it's a non-calculator paper, we haven't got one of these proportionality buttons on our calculator. So in order to be able to deal with this, we need to replace that alpha with equals K times 1 over X. Okay, so we replace this with equals K times, okay, where K is some constant that we need to work out, and they always give us information in the question to enable us to work out what value of K is. So we know in this case that when Y is 4, X is 6. So when Y is 4, X is 6. So into this expression now, we instead of writing Y, we can put 4, and instead of X we can write 1 over 6. We want to work out what K is. In order to get the K on its own, the times 1 doesn't matter because multiplying by 1 doesn't change anything, so we need to get rid of the divide by 6. Remember, in algebra, over 6 means divide by 6. The opposite of dividing by 6 is multiplying by 6. So to get rid of that divide, we times both sides by 6. So that gives us 4 times 6 equals K times 1, but that's just K. So K is 24. And what they want us to do is to find an expression for Y in terms of X. So I now know that if this is my relationship, K will always be 24. So Y equals, and instead of K I can write 24 times 1 over X. And that's my expression. Okay, so although it seems a bit obscure, that's the answer, which will get you the 3 marks. So for part B, complete the following table for values of X and Y. So what we've got here now is when X is a half, Y will be 24 times 1 over, and then X is a half. Alright, now if you've got 1 over half, 1 over a half, that's actually the same as 2. Okay, if you want to think back to fractions, what that is saying there is 1 divided by a half. And if you can remember your rules of fractions, in order to divide, you turn it upside down and multiply. So 1 times 2 is 2. So this is actually 24 times 2, which is 48. And then the second part of it, they're giving you the value of y. So if I just scribble that out of the way, when y equals 3, putting it into this formula, I have 3 equals 24 times 1 over x. Okay, now you could sort of work this out intuitively. This is saying 24 divided by something is 3, which is 8. Or you can multiply both sides by x to bring the x from the bottom of the fraction to the top. So you get 3 times x is 24. And then to get the x on its own, you have to divide by 3. In algebra, we write it like that. X equals 8. Okay, so you can either do it by saying, okay, so 24 times 1 over x is the same as 24 divided by x is 3. So 24 divided by some value equals 3. Well, the value must be 8. So this question, same setup again, look. Y is inversely proportional to x. Y fish 1 over x. Haven't got the fish symbol, haven't got alpha on my calculator, so I write that as y equals k times 1 over x. Now I need some values to work out what k is. I know when y is 2, x is 5. So 2 equals k times 1 over 5. To get the k on its own, I times both sides by 5. So k is going to be 10. So to get an expression of y in terms of x, we don't want to have that k in there. We want y equals 10 times 1 over x, which you can write as 10 over x. I could have done that in the previous one too. Okay, so complete the following table. So the first gap, when x is 10, y will be 10 over x. 10 divided by 10 is 1. When y is 20, into here, 20 equals 10 divided by x. So something 10 divided by something is 20, or multiply both sides by x to get it to the top of the fraction, and then to get the x on its own, divide by 20. 10 divided by 20 is a half. Next question, again, y is inversely proportional to x. Same start, y alpha 1 over, that means inversely proportional. What's it inversely proportional to? X. That's no use for me, I can't calculate with the alpha, so I replace it with k times 1 over x, then put in your initial conditions that you know. When y is 3, x is 10. So instead of writing y, I'm going to write 3. Instead of writing 10, x, I'm going to write 10. Get rid of the divide by 10, I times by 10. 3 times 10 equals k, so k is 30. So y equals, and instead of k, it's going to be 30 times 1 over x, or 30 over x. This again is a non-calculator question. Calculate y when x is 1.5. So y is going to be 30 divided by 1.5. Thirty divided by 1.5 is the same as 30 divided by 1.5 is 3/2. To deal with a fraction, turn upside down and multiply. So what we've got then is 30 divided by 3 is 10 times 2 is 20. Okay, you may have a different method for working that out, that's fine, but it's on the non-calculator paper. Calculate x when y equals a half. So when y equals a half, 0.5 equals 30 over x. Bring the get rid of the x underneath by multiplying both sides by x. Get the x on its own by dividing by a half. Okay, and again, whatever method you want to use here, that's the same as 30 divided by a half. You divide by a fraction, you turn it upside down and multiply. So the answer is 60. Okay, how you deal with that without a calculator is entirely, whatever method you've got that works for you, but you need to be careful. Alright, this one was off of paper 2, this one you're allowed to use your calculator. Same setup, y inversely proportional to x means we write y equals k times 1 over x. Y is 3 when x is 2. Three equals k times 1 over 2. 3 times 2 is k. Divide by 2 becomes times by 2. K equals 6. So instead of y equals k times 1 over x, it's 6 times 1 over x, or 6 over x. Right, when x is minus 1, y will be 6 divided by minus 1, which hopefully you wouldn't need a calculator for to work out that is 6 divided by 1 is 6. Positive, negative, signs are different, answers minus 6. But if you do need to use your calculator, then just remember you need to put the negative in brackets. So you do 6 divided by negative 1 minus 6, or use your fraction button to get 6 on top, negative 1 underneath, and you get your minus 6. Okay? And then for the second part of it, we know that when y is 0.1, we have 0.1 equals 6 over x. Bring the x up, or multiply throughout by x equals 6. To get the x on its own, we're going to divide by 0.1. Just multiply on that side, becomes a minus. 6 divided by 0.1, or to write it the same way, fraction button, 6 on top, fraction button, 6 on top, 0.1 on the bottom, 60. Okay, now it's not always y proportional x. You can see here that this time it's still inverse, so it's still y 1 over, but this time it's x squared that we're dealing with. Again, same thing, we can't deal with the alpha, the fish, the proportionality sign, so we replace it with y equals k times 1 over x squared. Then put in what we know. Y is 2 when x is 15. 2 equals k times 1 over 15 squared. 15 squared is 225. Get the k on its own, we have to multiply both sides by 225. 225 times 2 is 450, so k is 450. So y in terms of x will be y, so y equals 450 times 1 over x squared, or 450 over x squared. Calculate y when x equals 10. So y equals 450 over 10 squared, which is 450 over 100, which is 4.5. And the final question in this little bundle, again, y inversely proportional to x squared, y alpha 1 over x squared, y equals k times 1 over x squared. Y is 4 when x is 5. So 4 equals k times 1 over 5 squared. 4 equals k times 1 over 25. Multiply both sides by 25 to get the k on its own. 4 times 25 is 100. So k is 100. So y equals 100 over x squared. Find the value of y when x is a half. And we can write that on our calculator exactly as we see it, or we can turn, we know that a half is 0.5, but let's do it as with all the other calculator ones we've been doing, by writing it exactly the same way. So we've got a fraction. On top of the fraction we've got 100. Underneath the fraction we want another fraction, which is 1 over 2. And we want to square that. So there you go, you got the 100 over a half squared equals 400. The value of x when y equals 10,000. We have to multiply both sides by x squared to bring that from underneath the fraction. So we get 10,000 x squared on that side equals 100 on that side. Then we want to divide by 10,000. And then in order to find out what x is, you need to do the opposite of squaring, which is square rooting. So make sure you get the right number of zeros there, and then we can work that out again, make it look exactly as we've written it. So we start off with the square root. Inside the square root we want a fraction. On the top of the fraction we want 100. On the bottom of the fraction we want 10,000. So the answer to that is 1 over 10, or 0.1. So you can see there that those questions are very repetitive. You just need to make sure you've got the right variables, find out whether it's proportional or inversely proportional. If that question there had said directly proportional or just proportional, then what we would have written would have been 1 alpha x squared and then to get rid of the alpha, that would have become 1 equals k times x squared. Okay, so if it's not inversely, then it's just not 1 over, it's just times the value of the x squared. But as I said, all the examples I could find in the exam paper were all to do with inverse proportion.